it's possible in economics that we might have a function and we might be interested in its inverse. And so we're going to talk about what is an inverse function, what's a function. We'll review that in a moment. And the reason why we're going to do that is because it turns out that if we know what the function itself is, we can actually infer something about the derivative of the inverse function, even if we cannot explicitly solve for the inverse function. We're going to look at a couple examples where this is the situation. Now, to start with our review, so off camera, I have gone ahead and drawn a function. And we know this is a function. Blue line here, this curvy line, this is a function x squared. The black lines represent the graph. And we've got y here, x-axis here, and then this is 0 on the y-axis. Or I should say 0 on the x-axis. Well, both. And this is the origin down here. And this is a function. Notice that it passes the vertical line test, right? And when it passes the vertical line test, that really means that for each x, there is only one y, right? So if x is this value here, well, I should have drawn it down here. If we're at this x and we go up, there is only one y value for, say, this value here, x0, x naught. So for x naught, there is only one y, and we might call that y naught, which is how it's, that's the notation that's used in the textbook. Now I've added the next line. So we remember what a function is. Now there are special kinds of functions. There are functions called one-to-one functions. And these special functions that we did talk about, well, it was in the ALEX component of the course. It was in our pre-calculus section of the course. And for a function to be one-to-one, for each y value, there is only one x value. And so let's take a look at our example, right? We've got our function x squared. We know it's a function because it passes the vertical line test. Let's see if it's a special kind of function that's one-to-one. And we can actually use a horizontal line test. And so I'm using a horizontal line test. And x squared is not a one-to-one function. Right? It fails the horizontal line test. And that means that, generally speaking, it will not have an inverse. Does not have an inverse. All right, so that's a little bit of a review, but I may not have explained this explicitly in one of the videos before, so I'm talking about it now. This kind of function is a function, passes the vertical line test, but it's not this special kind of function where we can be sure it has an inverse function. Now, a function and its inverse have special property. And that property is that if we have f of g of x, that's going to be equal to x. Or I can write g of f of x, and that's also going to be equal to x. Now, taking a look at the inverse function theorem, I'm going to derive it in a second. Now, if f and g, or I should say, if f is the inverse of g, or the two of them together, one is the inverse of the other, then we can write our expression like so. Now, I'm going to take the derivative of both sides of this equation. If I take the derivative of both sides of this equation, I get the derivative of the outside. It's multiplied by the derivative of the inside, which is equal to 1. I can then write something like this. F prime g of x is equal to 1 over g prime x. And here is our inverse function theorem. The derivative of this thing, f prime, is going to be equal to 1 over the derivative of g prime. Now, we can go a little bit farther here. So if we're looking at this in terms of the y and the x-axis, consider a point x0 on some function. Maybe we'll make it, well, it's got to make sure that it passes both the vertical line test and the horizontal line test. And suppose we're interested in x0. And if we know what x0 is, then g of x will give us y naught. Right? So if I can rewrite this just a little bit, I've got f prime of can I add this? Make this a little clearer for you. G prime, or not a prime, just g x of 0 is equal to y naught. And so we could have g x0 like that is equal to 1 over g prime x0 or x naught. Sometimes we call it x naught. And the left-hand side becomes f prime of y naught is equal to g prime of x naught. So, and if I draw the inverse, it's going to look something like that. We've got f of x going off in that direction, and this dotted line represents f of g of x, which is just a 45-degree line that's always equal to x. Now, before we jump on to the next topic, let's finish working with this diagram. This point here is x-coordinate x naught, comma g of x naught. And the slope at this point is equal to g prime x naught. What's its corresponding inverse? Well, it's going to be somewhere over here. What's that coordinate going to be? Well, it's going to be xg naught, comma x0. So the y and the x-axis switch. And the slope here is going to be f, well, let me write this as 1 over f prime y naught. All right, here's our example. So we've got this function. It is a higher order polynomial. And what can we say about it? Well, one, I gave it away. It's a function, right? It passes the vertical line test, and it also passes the horizontal line test. So passes horizontal line test. So an inverse exists. I should say an inverse function exists. Now, what point are we interested on? Well, we're interested in 1, and maybe I'll just replace that with an x. Replace that with a c. We're interested in 1 and 7. So we're interested in this point here, 1, 7. And we would like to know what the slope of the inverse function is that corresponds to this point. So if we name this thing down here g of x, then we're going to be able to find g of x naught, g of prime naught x naught, and we're going to be able to infer something about the inverse of this thing, and this is where it's getting kind of hard to write, inverse prime around y naught. So that's what we want to find. We want to find this here, and it's going to appear somewhere on this diagram such that the two functions together, when the two functions interact with each other, one's embedded in the other, we just get x. So let's take the derivative of this thing with respect to x. So we're going to get y prime is equal to 5x to the power of 4 plus 9x squared plus 6. And if I call this thing g prime of x, and I want to know what g prime x naught, g prime when x is equal to 1, I'm going to get 5 times 1 to the power of 4 plus 9, 1 squared, plus 6. And that's just going to give me 5 plus 9 plus 6. And so g prime 1 is going to be equal to 20. And I know that if x naught is equal to 1, then y naught is equal to 7. So if I'm interested in knowing what the inverse of this thing is, evaluated at y naught, it's going to be 1 over f prime x naught. And in this case, that's just going to be 1 over 20. So if I go back to our diagram and I look at the point of interest that we started with, it turns out that the slope here is 20. And that's at coordinate 1, 7. And the inverse function has a slope of 1 over 20 at 7, 1, coordinates 7, 1.